All right, we're gonna get started here. Thanks everyone again for joining. Really appreciate it. Looking forward to this. I'm Nate Mason, principal here at Starburst. I'm an electrical engineer and retired master sergeant from the Air Force with more than 20 years of service. I've spent my career inside of the innovation ecosystem, not only building hardware, but software, defense solutions. And for the past several years now, I've been working with startups, and I really love helping entrepreneurs achieve their dreams. Starburst, we're an innovation services, venture capital, and consulting firm. We're really aiming to advance key technologies to drive national prosperity. And at our core, we are a mission-driven firm seeking to advance deep tech with not only commercial, but defense applications to make the world more connected, sustainable, and safe. Today, we are excited to have 5 new startups pitch about technologies they're developing. These startups are part of our inaugural Sustainable Aviation Technologies and Energies Accelerator Program. It's a partnership with the Aerospace Futures Alliance, a 501c6 nonprofit in Washington State's Trade Association for Aerospace Companies and Communities. Aerospace Futures Alliance was recently awarded an EDA grant through federal funds through a Department of Commerce Innovation Cluster Accelerator Program, ICAP, and this is to form a state cluster with the mission of leading and encouraging the research, development, and deployment of sustainable aviation fuels, electrified and hydrogen-powered aviation, IT tools for operational efficiencies, and propulsion systems. Today, we're going to begin with the keynote from the CEO and founder of Ampaire. It's a Starburst portfolio company, Kevin Noertker. So over the past 7 years, Kevin and his team have pioneered practical, compelling electrified flight through the upgrade of existing aircraft types. In 2019, they flew the world's largest hybrid-electric aircraft. And in 2020 and 2021, they developed and demonstrated electrified flight with multiple airlines across the globe. With over 23,000 miles flown via a hybrid and more than 12 plus regulatory flight approvals across 3 continents, 3 countries to date, they're a leader in hybrid electric aviation. Prior to Ampaire, Kevin contributed engineering and program management expertise to advanced aircraft and satellite technology development programs at Northrop Grumman, and as a research fellow at Caltech and NASA's JPL. An entrepreneur at heart, Kevin is driven to apply the science and engineering disciplines of large aerospace organizations in pressing environmental problems here on Earth. Everyone, please welcome Kevin to the stage.
Thank you, Nate. Really appreciate the introduction there. So I appreciate the detail that Nate just went into. It caused me to think back on the first conversations that I had with Starburst. So this is back in 2017 in the summer. I mean, really both organizations getting started up, thinking about the future of aviation and space, thinking about how do you build an industry, how do you build an ecosystem, how do you drive toward big, audacious goals together. And so here over the coming 15 minutes or so, I'm going to share a little bit about our story, a story that has been 8 years in the making. We're coming up on our 8th anniversary as a company, about building Ampaire, which is one of the leaders in hybrid electric aviation. We jump to the next slide. You know, when I was thinking about this, as an engineer, I was thinking about the compression ratio here. This is a 280,000 to 1 is the 8 years down to 15 minutes that I'll be presenting. So just a small sampling of the real deep, challenging, exciting, motivating experience that has been building this company. And so what I hope to share today is a bit of that history, some of the stories, some of the lessons learned, as well as the principles that have guided us from where we began to where we are today, and certainly which I plan on driving us as we head off over the horizon into the future together. But before jumping in, I'd love to start with a video, and as we saw those, that compression ratio of 28,000 to 1, this is just one moment experienced within the Ampaire team, just one moment across those 8 years, which I would love to share with you here. So if we could get the video started, thanks.
We're here at the Camarillo Airport witnessing our first hybrid electric flight on Ampaire's Eco Caravan. It's our first commercial intent product, slated for certification in 2024. The Eco Caravan is the first commercial application of this operating system for electric aviation that Ampaire is building. One that we intend to take into larger planes with higher capacity, longer range and endurance and payload. A very exciting future, the foundation of which we're beginning today.
A significant fuel reduction, 50 to 70% in terms of fuel and maintenance combined. That is transformational for any airline, for any operation.
Clear to 1 Camarillo Tower, runway 26 cleared for takeoff.
1, clear for takeoff, runway 26 left.
Your number 2 following traffic, short final, runway 26, clear to land.
1, clear to land, runway.
A hybrid electric aircraft is actually going to be able to fly people and cargo. Just landed, had a successful first flight.
Yeah, the team's worked so hard, and this is such a magical day for all of us.
So it's moments like those that are magical for teams, for the industry, and that really are. I mean, I personally can't watch that video without getting a big old smile on my face, thinking about all of the effort and work that we put into that milestone, which was back in 2022, flying the Eco Caravan, which you see over my shoulder. And as we build companies, as we build relationships across this industry, I think it's imperative for us to find and celebrate those milestones as we go from 0 to 1 to 100 as solutions, and to celebrate how we get there. So where is Ampaire today? We've flown 25,000 miles in our hybrid electric planes. We've got the world's largest fleet of hybrids. That's 3 planes based in Southern California, all piloted. We have taken a strategy which has delivered unmatched and really unparalleled results of efficiency in trying to deliver these solutions scalably and rapidly. So, for example, this looking at the number of flight miles that we've achieved on our systems, and relative to the capital that's been allocated, driving toward big positive impact. So we've certainly come a long way. But next slide, if you think back to where it all began, these types of stories, and many of the companies that are pitching today, have very, very humble beginnings. So I'm an engineer out of Caltech, program manager out of Northrop Grumman. My co-founders, engineer and business guy, came together in late 2015 just with a dream of what the future could look like. Pretty cool sketches of what it might be, and built from the ground up, starting in a free garage that we had, borrowed office space, no salaries, investing your life savings, like that whole type start back in 2016 for us. And in building from there on the big vision, but taking thoughtful, practical steps toward implementing it. So there on the bottom left, you see our very first hardware, which was about a potential integration, a thermal integration of pouch cell battery packs into structure of aircraft. And as you can see, very high-tech start. Our first aircraft, full-scale model that we built in the yard of one of my co-founders' parents' houses. So again, very humble beginnings there. And if we jump to the next slide, we established in those moments as a company who we were, why we were, the mission of the organization, and as you can see, the three words that are on this slide are the three keywords that are in the mission of Ampaire. Our mission to be the world's most trusted developer of practical, compelling electrified aircraft, from short-haul cargo through supersonic passenger transport. But at the front, trusted, practical, compelling. These drive into all of the decisions we make, how we act within the world, how we hope to be perceived, and certainly the types of products that we look to bring to the market. And this is through all of the flights, some of which are depicted here, our sustainable aviation fuel demo, which we completed recently, that 12-hour endurance hybrid flight that we did last year, island hopping in Hawaii, flying up to Alaska, deploying in the UK, and all the amazing milestones in between. Trusted, practical, compelling. By defining our core values up front, we have been able to set a compass for the company and measure our progress according to that compass, which provides a important guiding factor for the organization. So if we jump to the next slide here, those guiding principles then drive us to act with urgency, because as we all here today believe sustainability, decarbonization, these are really important things for the world. We believe, again, based on this trusted, practical, compelling, that we cannot wait for novel Nobel-winning prize type technology or crazy infrastructure investment as a prerequisite to making progress. It can happen alongside progress, but not as a prerequisite that guides the decisions we've made. We believe that scalable solutions are fundamentally economically amazing, that they make economic sense both for us and for our customers without relying upon subsidies as a prerequisite to success, because that drives broad affordability and market adoption. And then we believe that any real solution to solve the global challenges that we're facing must have broad applicability across many markets, and that this is the biggest opportunity in decarbonization, a once-in-a-lifetime opportunity as big as the jet age, and it's happening right now, and we need to move fast on it. So next slide. So this drives us into going from those core principles into, well, what are the factors upon which we should be applying those principles, and thinking through the challenges and as you face as a startup. Ours, we really focused in on the technology, the infrastructure, the applicability, and the safety. And for our hybrid electric systems, which is what Ampaire has developed and is commercializing, we believe that the path to zero emissions begins with real thoughtful action today on technology that's viable today without significant new invention, that alleviates the risks of, for example, as I'm sure everybody here recognizes, battery energy density, or the range anxiety that comes with it, or from the infrastructure side, de-risking the charging infrastructure. So like when you jumped into your Toyota Prius, decades ago, it was because, well, charging infrastructure probably wasn't available for fully electric, which is why they hadn't scaled yet. So similarly, we eliminate barriers to entry and those infrastructure challenges that otherwise would cause scalability and market address challenges for new technologies. When we think about applicability, it's about how do you find the picks and shovels approach, the scalable solution that serves broad use cases rather than the niche application. While it's important to launch in a niche that highly values what you do, it's always critical to think about scale, because scale is how you drive big impact. And in aviation, safety is absolutely critical. So it's the redundancy, having the safety of a twin in our hybrid packaged into a single engine. So those are factors that drive our actions and how we've overcome and addressed some of the challenges. But if we go to the next slide, we'll see the launch product. So all that combines into this question of how do you launch a product? What product should you launch? What's the value proposition there? So our upgrade to the Cessna Caravan, which we call the Eco Caravan, flight testing, getting the sales, having the 50 to 70% fuel burn reduction, driving operating costs down, dropping into existing operations. These are the key factors on that we've uncovered as we launch. And on the next slide, this question of, okay, well, if that's where we launch, how do we scale? Where does it go from here? You know, caravans, 9-passenger planes are good, but larger planes are broadly applicable. The twins, the larger planes, the new build, eVTOL and such. Each of these are pieces of that scalability. And as each of these companies will grow, it'll be important for them and always to keep in mind that scalable application where you have a single core technology innovation that has broad applicability. And then the next slide, when you look at how you scale, it then goes into what markets should you address. And so for us to build a resilient company, we address both the commercial aviation market, cargo and passengers flying around the world, both domestic and international. We also look at the defense industry as a major customer. We work with the United States Air Force, got Department of Energy contracts, NASA contracts, and then the future novel applications like vertical takeoff and landing, taking what we believe is that building blocks approach, broad scalability, taking that same component and allowing it to serve many markets. You go to the following slide. And so this is how we've thought about the opportunities, how we've thought through the markets, the technology, the application of the value proposition. And along the way, there are 1,000 bumps in the road and interesting and exciting opportunities, whether that's building out the team or going to raise capital. Ampaire is raising capital, so there's an opportunity if folks are interested to reach out to me on that. Building a resilient revenue stream, going and dealing with the realities of delays in product launch, or the regulatory challenges, and partnering with those organizations to help educate them and bring the industry forward, or mergers and acquisitions. Like this photo here is of a recent acquisition that we announced last week or earlier this week on Monday, where we are bringing in technology and relationships and phenomenal talent from other organizations as we see consolidation in this exciting and dynamic area. So on to the final slide here. This is an opportunity which we should not try to go after each on our own. The industry is better together. It's important for us to bring the different technology solutions, the sustainable aviation fuels and the hybrids that burn half as much, the novel technologies and the existing markets that they're applied into, the technology developers as well as the ecosystem infrastructure maintenance operators. And in each case, it's by bringing that community together that we're able to achieve the audacious and exciting goals that we all have. So with that, I'll end. Here's a QR code. Scan it if you'd like to connect on LinkedIn with me. You've got my email there. And congratulations to the 5 companies here. Thank you to Starburst for your support over all these years. And let's go build an awesome world together. Thank you.
Thank you, Cam. Thank you so much. That was amazing. We really appreciate you being here, sharing your perspective, and that video was really inspiring. Thank you so much. Next up, we will have our pitches from the 5 companies in cohort 1. So next up is New Frontier Aerospace. New Frontier Aerospace is manufacturing advanced propulsion for space and hypersonic mobility. Led by Bill Bruner, New Frontier builds advanced rocket engines to power multiple products, to include orbital transfer stages and net carbon negative hypersonic aircraft for civil, commercial, and defense applications. The stage is yours, Bill.
Thanks, Nate. Much appreciated. Hi, I'm Bill Bruner, CEO, co-founder of New Frontier Aerospace. We build, as Nate said, 3D printed propulsion systems and renewably fueled hypersonic VTOL aircraft that can get cargo and passengers anywhere on Earth in less than 2 hours faster, and cleaner than jets. Next slide. Today, 65 years into the jet age, air travel is slower than it was in 1958 when the jetliner was introduced. Back then, the Boeing 707 jetliner had a cruising speed of 600 miles per hour. Today, Boeing 777 cruises 38 miles an hour slower. So it takes all day for an intercontinental flight. Anybody who's flown across the Pacific or Atlantic knows this better than I have. Every year, passengers spend over 10 billion hours on flights of 10 hours or more. Patients die waiting for transplant organs. Troops suffer in the field for lack of ammunition or logistics. Air carriers lose billions of dollars every year when their aircraft are grounded awaiting parts. In addition to being too slow for the pace of modern life, today's jets spew 1 billion tons of greenhouse gases into the atmosphere every year, and they need runways that consume thousands of valuable acres around all of the major cities on Earth. Next slide. The solution is to use a modern engine that runs on bio-sourced renewable fuel to propel our vertical landing aircraft on a comfortable hypersonic flight to many more places where there are many more customers than today's aircraft can serve. Over 10,000 heliports in this country, for example, with passenger lounges and or refueling. That's compared to less than 3,000 supersonic runways long enough to accommodate the supersonic airplanes that some of our competitors are trying to build. Our use of biosourced renewable liquid natural gas from agricultural and other waste products stops methane emissions at the source. Combined with combustion that's up to 60% cleaner than Jet A, we can help our airline customers reach their net zero goals earlier than synthetic or hydrogen fuels. Next slide, please. ARK Invest estimates that the hypersonic travel market will be $270 billion by 2040. Our bottom-up numbers using today's first-class airfares support that projection. On the cargo side, the analysis we've done, request of a major U.S. air suggests that the rocket 85%, and the rocket liner's dual-use technology. The military is investing tens of billions of dollars in hypersonic platforms for everything from rocket cargo to one-way missions. In fact, DoD's funding our engine. We're in a conversation with the department in pursuit of these missions. As one example, we were one of 5 innovative small companies selected to present our concept to the Pentagon's Joint Hypersonic Transition Office at the University Consortium for Applied Hypersonics meeting in Austin next week. That's a lot of words just to say that the DoD is very interested in our idea. Next slide, please. Because 3D printing radically lowers the cost of development and manufacturing, our production cost will be a fraction of our competitors. For example, this engine that I've got right here, 3D printed, 2,500 pounds of thrust, the same thrust in the T-38 I flew when I was flying jets with the Air Force. This engine costs single-digit millions to develop, and we're going to integrate it and put it on the test stand in a few weeks. We've already fired the pumps that you just saw successfully, and we're moving on to the fully integrated test fire soon. 3D printed aircraft production costs will be similarly low, and our fuel costs, even when renewably sourced, will be pennies on the dollar when compared to fossil Jet A. All this combines to create a product that's 10 times faster at the same or lower operating costs than today. Next slide, please, Alana. So we've raised $200,000 from our friends at Kepler Space Ventures. We've won, and a couple of angels. We've won $2.5 million in awards from DoD and NASA to build the engine. We've executed on a $25,000 contract with Lockheed Martin Space Systems to validate our 3D printed aircraft concept, and we've received $133,000 in non-dilutive grants from the New York State Energy R&D Authority through the Venture for Climate Tech Accelerator. Plus, we have letters of intent from companies that wish to use our aircraft for their missions and others who want to buy our engine. So we're moving. Next slide, please. So I'm the CEO. I was a presidentially appointed senior manager at NASA, fellow in the Office of the Speaker of the U.S. House of Representatives. I went to the Air Force's Top Gun School, the Fighter Weapons School, was a supersonic aviator for the Air Force. So I can't wait to go faster than supersonic to hypersonics. David Gregory's our COO. He printed the first 3D printed regeneratively cooled rocket engine. He developed America's first oxidizer-rich stage combustion engine. He was the lead propulsion engineer on the BE-3 rocket engine that launches people into space on the New Shepard vertical takeoff and vertical landing rocket. So he has the distinction of building the engine that was the first ever to launch people on a VTOL rocket vehicle, so eminently qualified. Jess Spottable, our president and CTO, managed multiple reusable launch demos and hypersonic weapons program in the Air Force and at DARPA, and he was the program manager that built history's first vertical takeoff and landing rocket, Delta Clipper Experimental. And our board chairman is Alex Tai. Alex was the co-founder and COO of Virgin Galactic, the first chairman of the Commercial Spaceflight Federation. So we've got a top-tier team and their experience of doing this and have flown vertical takeoff and landing rockets before. Next slide, please. Thank you. So here's the obligatory comparative chart. We are faster, cleaner, and more affordable than our competitors. And we've got on this chart your canonical supersonic competitor, can't fly Mach 5, can't get it to 8,000 miles of range, has a pretty loud boom because they're low compared to us. They burn synthetic aviation fuel or Jet A, which isn't any, SAF is no cleaner at the tailpipe than Jet A. And it costs a lot to slug through the atmosphere at those altitudes. So we're bragging on ourselves. SpaceX can go as fast. They use methane fuel. They could make it renewable just like us. However, that vehicle is going to cost more than we cost to fly. It's the size of a skyscraper, and it's going to require a lot of infrastructure at both ends to do the point-to-point mission. Next slide, please. So how do you make money? You print vehicles and you sell them for more than it costs you to make them. So a Gulfstream costs $100 million at that price, and a $50 million per airplane cost of goods sold. That's a 50% margin. The charter airplane market, this bizjet market, is about $60 billion, and we see ourselves at $1 billion in revenue 9 years after our first flight. That's enabled by low production costs and 3D printing. And we see that this is going to be huge, and that doesn't include military. That's simply commercial jet sales. Next, please. So our go-to-market plan is to start selling the engine now as a product to NASA and small space companies. We are also currently selling the first version of the aircraft, the Pathfinder, into the DoD sales channel, where we have an extensive Rolodex. We've begun customer discovery conversations with large air express cargo companies and charter operators, and we have a LOI from a major hospital system to carry medical logistics when the aircraft is ready. Next slide, please. So last slide, this is our call to action: invest to win. $5 million to get the engine tested and ready for sale as a product. Further $30 million to print the 3-engine version of the airplane. That gets us to hypersonic VTOL flight and MVP. This airplane would not just be a proof of concept, it would be a revenue earner, flying cargo for military and civilian customers, conducting affordable routine hypersonic tests that our country hasn't been able to do since X-15 flew in the 50s and the 60s. If you have more questions, route them through Nate or send them directly to me, bill@nfaero.com. November Fox Alpha Echo Romeo Oscar for you flyers out there. Have a great day. Thanks for your attention.
Thanks, Bill. Really appreciate that. Next up is Avol Aerospace. Avol Aerospace focuses on same-day drone delivery of bulky items. Led by Nate Poon, Avol builds novel, dual-use autonomous electric drones enabling delivery to hard-to-access rural areas. Their solution has use cases in logistics, aerospace, medical, deep tech, and climate domains. Next up is Nate.
Hey everyone. Cool. So hey guys, my name is Nate. I'm one of the founders of Avol. Our goal is to enable faster, more affordable flights anywhere in the world using autonomous electric aircraft. Next slide. So before I get started, a brief snapshot on who we are. We have 9 pilots with different hospitals across the US to deliver medical supplies. We're 2 PhDs out of Berkeley and Cambridge. Both of us have started at least 3 companies and exited at least one of them. The aircraft that we're building has significantly lower manufacturing costs, but we make about 72% gross margin for every delivery that we make. And we raised just under $750,000 last year from both investors, but then a series of government grants with the DOE and the DoD. So the fundamental challenge with aerodynamics is that you have the existing inefficiencies of existing aircraft. So most aircraft today are basically a tube with a couple of wings on them. So you have the rear empennage, which is the rudder and the elevators that create a lot of drag. You have oversized main wings, and then you have a fuselage, which doesn't generate any lift. The net result of this is that you have an aircraft that is extremely high drag, and that translates to extremely high operating costs. You also have limited interior space. So for those of you with a logistics background, you guys have probably heard the phrase cube out before you weigh out, meaning that you always hit cubic capacity, volumetric capacity of an aircraft before you hit payload. And then these aircraft require really long runways because they're not terribly efficient at generating lift. And so one way to make a much more efficient aircraft, one way to do a much more efficient aircraft is to do something called a blended wing. So blended wings are significantly more efficient. Instead of being a tube with a couple of wings on it, these aircraft, the entire aircraft is a wing. And so you get a much more higher, you get much more lift per unit of drag, which means you're more aerodynamically efficient, you have more range. We have more cargo volume capacity to carry more cargo, which improves the unit economics of whatever you're carrying in the cargo bay. And then because the aircraft is so efficient at generating lift, you can operate from very short runways. So there's been a couple of attempts to do this, but the challenge is extremely large aircraft like this are extremely difficult to build. To give you an example, Nautilus, Jet Zero are also aircraft building very similar blended wing aircraft at a much larger scale. They've taken 8 years, 6 years to do this, and still no real large scale prototypes. So these types of aircraft are very difficult to build. Next slide. And so the thesis behind Avol is to build small, autonomous blended wing drones that can deploy immediately. When you build small blended wing aircraft, you can get FAA approval faster. You can start generating revenue immediately within a standard VC timeline of about 5 to 6 years. We could get you about $100 million in revenue. And you can build a regulatory precedent for building larger aircraft based on that airframe. And so that's the general thesis behind why we started Avol. Next slide. So the problem we dialed in on was delivering things between hospitals. So right now, medical deliveries between hospitals are extremely slow. About 1/3 of transplantable kidneys are lost because transit between hospitals just takes too long. Each kidney has a value of about $2.5 million each. So at about 12,000 kidneys every year, that's about a $30 billion problem just because we haven't figured out how to deliver kidneys between hospitals quickly. You can extrapolate that to anything that enters and leaves a hospital. So blood, organs, biopsies, vaccines, pharmaceuticals, which comprise about 44 million deliveries every year. So we believe that this is a pretty compelling to solve that small lightweight drones are particularly useful for solving. Next slide. The challenge is that hospitals face is that their only options right now are medical couriers. And so medical couriers are ground-based drivers. They take about 4 hours to arrive to pick up your payload, and then they transit for about 2 to 4 hours, which means that it takes roughly about 8 hours for a medical courier to complete what should be about a 2-hour drive. Next slide. So at this point, a lot of people go, well, we could just use drones, right? The challenge is that existing drones typically start with an airframe and then try to adapt that to a hospital. And I spent 10 years doing hospital logistics. This approach doesn't work because hospitals are some of the most risk-adverse, custom-tailored customers that exist on the planet. And we see this in stalled efforts with drone companies with engaging with hospitals. Zipline requires you to put in a catapult or a runway or to engage with their warehouse. Matternet and other drone companies require that hospitals switch out their boxes or switch out their hardware protocols to use them. And then quadcopters, because they're so inefficient at generating lift, they have really low and small endurance time, so they require multiple handoffs. Next slide. And so with this aircraft that we're building, it's designed specifically for medical cargo. If this is a video, so if this was a PowerPoint presentation, you'd see the aircraft take off and fly. It has 60% more volume for the blood and organ boxes that a hospital already uses. It has 41% more range, so it can fly between the hospitals, the distances between hospitals and medical centers that are currently flown or driven. And it can take off and land vertical, so VTOL. So it can take off and land at any parking lot on the planet. Next slide. The aircraft is 3D printed. Again, this is a video, so if anybody would like to go on and follow up with me afterwards, I'm happy to show you all the videos that we have. The aircraft is 3D printed, which means that to scale up production, we don't need a factory. We can get a small warehouse, put a couple of 3D printers in there, and be printing roughly between 150 to 200 aircraft per year. Next slide. What makes the unit economics work here is that we own the entire delivery process. And so we actually have human drivers pick up and deliver the kidneys, and then the drone flight occurs in the middle of that. So the driver picks it up, we have a drone flight, and then driver delivers it at the other side. We do take a hit on the margins, obviously, but the upside is that we're able to still generate about a 72% margin per delivery, but we're able to target 3 to 4 times more customers than drone companies that are trying to fly in urban areas. Regulation to fly over urban areas is not very well developed. And so by using drivers, we're able to take the kidneys and the blood out of the urban area and fly it from a more rural area, which opens up our market by a factor of 3 to 4. It also gives us a unique go-to-market. Oh, no, go back. It also gives us a unique go-to-market strategy where we can enter a new city and just use drivers to deliver blood and kidneys initially, and then cut in the drones as they achieve regulatory approval. So by using this approach, we can enter a new city about 12 times faster than a drone company because we don't have to get FAA approval. This allows us to kind of scale across the United States, build a network of customers that love us and use us, and then cut in the drones to increase our margins by up to 70% for our initial go-to-market strategy. Next slide. The aircraft that we operate is a small aircraft, so typically it might take 5 to 7 years for you to get your type and production certification with a larger aircraft. Because we are a small blended wing aircraft, we can take advantage of the Part 107 waiver, which allows us to get to mainstream operation in about 3 years. But the caveat being, we have to be under 55 pounds, fly lower than 400 feet, and fly over empty areas. This is the use case that we've optimized for aircraft, for hospitals, and it seems to resonate extremely strongly, specifically with hospitals in rural areas. Next slide. Our model is straightforward. We charge a delivery fee for every delivery. So there's about 44 million medical deliveries that occur annually. We can charge anywhere between $500 to $1,500 per delivery, resulting in roughly about $2.3 billion in revenue if we penetrate 10%. That 10% is just driven by what one of our competitors, Airspace, currently 1 in 10 hospitals using the airspace. We believe we could achieve probably about the same volume. In about 5 to 6 years, our trajectory is about $100 million in revenue after we raise this current round. Next slide. Ultimately, though, the goal here is to use Avol to deliver anything, anywhere. So regardless of whether it's a small package or a large package, we know that different aircraft have different niches. I think Kevin was alluding to this earlier. And so our goal is to build a fleet of blended wing aircraft that caters to every niche of this market. We estimate the global market for global air transport is about $700 billion. We think that we could probably get maybe 20% of that by just building larger aircraft based on our blended wings. However, we're going to start with hospitals because I spent a lot of time actually selling into this market, and we can start to generate revenue very, very quickly with small, easy to certify aircraft. Next slide. So this is the team. We have 4 ex-founders from medical logistics, aerodynamics, and robotics. This is my 3rd company. I spent the past 10 years building robots and AI for medical and logistics applications at Amazon, Tesla, DHL, Delta. My last company, we exited to Autobot. Matthew, this is also his 3rd company. His last company, he exited to a private equity firm. He spent 5 years building blended wing aircraft and built some of the foundational research behind the Boeing blended wing. And then DR and Farhad are kind of the Swiss Army knives. Farhad handles manufacturing, DR handles controls. but all of us have started companies and run them. So next slide. Our advisors come from companies you may be aware of: Zipline, Ground Force, Park, Drone Racing League, Airbus, and Relativity. Next slide. And we're currently raising $2 million. That gets us to commercializing Avol 10 within the next 18 months, which we're on track to do, and then hiring somebody full-time to expand to about 10 hospitals in the US. I'm putting my email in the chat. If anybody would like to connect with me afterwards, we'd love to chat. There's a lot of videos that didn't show here. So if you're interested in taking a deeper dive, please reach out. We'd love to chat. Thanks.
Thanks, Nate. And for everyone's reference, we will be sending out more information on all of the startups that are presenting today. So if you want to, you can take their email through the chat now, or you can wait. We will be following up with everyone that's been registered for the webinar. So next up is Kaiyo Technologies. Kaiyo Technologies is making SAF feedstock at the cost and scale that aviation needs. Led by Dan Brown, Kaiyo Technologies is developing the technology to cultivate microalgae in the sea without the use of land, fresh water, or electricity at a cost and scale to make SAF practical. The floor is yours, Dan.
Thanks, Nate. Hi, my name's Dan Brown. I'm CEO of Kaiyo Technologies. I've spent most of my career designing airliners to make them more fuel efficient than the previous generations. The problem we've had with that is that we've been too successful, because the better we make them, the more people want to fly, and the bigger the problem that aviation presents in terms of global emissions. The industry realizes this is an important issue, and the IATA and the other airlines are dedicated to get to carbon neutral by 2050. Next slide, please. And therein hangs the problem, is that the most practical way we will get to 2050, which is not that far away when you consider it takes 10 years to make a new aircraft design. The whole thing just takes so long that the only practical really way of getting the industry to net zero by 2050 is through SAF, sustainable aviation fuel. And SAF is brilliant because it's a drop-in replacement. There are lots of different ways of doing it. We've got lots of technology has already been spent on the different pathways. The problem is we don't have enough feedstocks from the existing land-based solutions. We don't have enough land on the planet to make the solution, to make enough SAF without negatively impacting other people who already want to use those resources. So, and it would take 1/6 of the world's cropland if we're going to use vegetable oil from canola. And Lufthansa works out that justify their aircraft fleet on SAF, eSAF, would take half of Germany's electricity. So the problem is the land's not big enough. So next slide. The solution we're looking at is implementing is algae, marine algae, growing them in the sea, which is their natural environment. So we're not using any land, we're not using any farmland, we're not using any fresh water, not using anyone else's electricity. So it's just a different way of looking at the problem. And what we're looking to do is that we know that in the past there's been a lot of experience, a lot of money spent on biofuels from algae. In the last decade, that was all genetic engineering, where we were genetic engineering marine algae to grow in a pond on land. What we're doing is mechanical engineering to engineer an environment in the sea which best suits algae. Next slide, please. And just as a point, the productivity, the reason for algae is the productivity. You can get more biofuel out of an acre of algae each week than you do out of an acre of canola oil in a year. And we will do that week in, week out. So we don't make all of our fuel in 2 months and then have to store it for the rest of the year as we use it. So the concept is to have enclosures under the water where we keep our algae in there under sunlight in natural seawater. And then we have a circular system by which we grow the algae, we process them to take out all the hydrocarbons and the carbohydrates that we can use to make ethanol. And everything else, the byproducts, which normally would be counted as waste, well, that they are our nutrients. They contain all the nitrogen and the phosphorus that we need to grow the next generation. So that's the concept. This is a modular system that can be scaled up to cover acres, thousands and millions of acres. Next slide, please. So the competitive advantage we're looking to do is we're first in the industry. No one else is really doing this. There are lots of people who are trying to grow algae on the land. There are lots of people who are trying to grow large seaweed in the sea, one or two that, but no one's really doing what we're doing. So we're going to be there first. We've already got the patents lined up to make this work. And through what we're doing, we will find the best strains of algae, which we can then safeguard. And as we're going to be ahead of the curve, first in there, we will be ahead of the curve. Next slide, please. Okay, our business model. Ultimately, I would prefer not to become an oil baron because I don't have the expertise in making fuel out of raw materials or delivering that to a customer. So what we're looking to do is we have a licensing model where we license the intellectual property to build of the drawings to make our stuff to existing oil and gas offshore oil and gas manufacturing companies to make the stuff, and then we take a profit, a scheme off that. We could directly invest, so we can set up our own oil rigs, buy oil rigs, our own algae rigs, and sell that product direct to the market, or preferably we can team and form joint venture companies with strategic partners such as oil companies, governments, etc., etc. And then at that point, that's long-term investment with that company, long-term revenue stream. Next slide, please. Okay, so I've said a little bit already about how we compare that. Algae, microalgae, are grown much, much faster than anything that can grow else, or any land-based crop. The problem with most of the approaches they were taking is they use open raceway ponds, which still take up quite a lot of land, and they still need a lot of water. So the idea of us is that we get rid of those major impediments, and we also grow algae where where Mother Nature has tuned them for the last hundreds of millions of years to grow in their ideal conditions. So we're meeting Mother Nature halfway, and we'll be more productive and less competition with the existing less resources as a result. Next slide, please. Well, the team at the moment, the team is basically me. My experience is I've led teams of engineers in aerospace industry of over 100 engineers, and I need to grow that team, and that's one of the things I'm looking to get funding to help me do. Next slide. Right, our go-to market strategy is that because we are producing basically raw bioproducts, one of the first major markets is actually not aviation or anything else. It is vegetable oil. In the same way that one of the main mains of making SAF is taking used vegetable oil and converting it into SAF, what we're effectively making is vegetable oil, which retails at more than 2 or 3 times as much per gallon as crude oil does. So that's where we would start. And as we learn to do this better and better, as our costs come down, then we can grow into sustainable aviation fuel. And then ultimately, when we get the costs really down, it completely open up to be a direct replacement for crude oil. Next slide, please. Okay, we still need to prove out the concept to people. And so we're looking to spend as little money as possible by having a three-phase stage to get to where we have ultimately a rig one operating in a sea, which is generating about $8 million in revenue. And so it's covering its costs, and it's there to show the world that the technology works, and set up partnerships with us. And so what we're doing now is lab testing and CAD work, engineering work, moving into field testing. And once we have reached our milestones for the first stage, and then on into getting rig one, around about a total of 20 million investment for all of that. Next slide, please. And so our ask for the moment is the seed funding of $500,000 to get us to the point where we have a schemed out design for our prototype system, which will use all the modules that will end up in the big system. We can learn and get everything and then raise the money at that point to put our prototype into the sea. I thank you for your time.
Thanks, Dan. I really appreciate it. Next up is Avium Digital. Avium Digital is designing the SaaS solution that will lead the advanced air mobility revolution. Led by Frederic Chambour, Avium System of Systems achieves unprecedented real-time connections between VTOL and emerging advanced air mobility infrastructure, providing an effortless urban travel experience within a city's vertiport network. The stage is yours, Frederic.
Thank you. Hello, everyone. In 2022, I was attending a business aviation convention in Orlando, Florida. While I was looking for some business opportunities, I went on to visit the new hall dedicated to innovation. And that is where I saw for the first time those electrical multicopters and vector jets with cabin ranging from 2 to 4 seats. The new mobility segments for the urban environments. That was very exciting. While talking with the founders of those innovative enterprises, I realized that everyone was focused on the investment for aircraft OEMs and ground infrastructure. They had those vertiport models from where eVTOLs will take off and land. But no one was really thinking about the technology that will actually combine, synchronize, and operate these assets. I spent my whole life solving business problems using technology. In my last position at the head office of one of the world's largest airline group, I was tasked to recover a declining B2B business. I teamed up with Oracle Innovation Task Force then, and together we developed a machine learning that predicts future travel needs of corporate executives. The prediction capabilities exceeded our expectations in precision as well as in revenue. From this success, I knew that airport software providers do not have the innovative culture required to operate vertical ports in urban environments, especially as their purpose is to be integrated and complementary to the existing mobility systems that the city has. And I verified this as a customer. That's why at Avium, we develop a SaaS to automatize infrastructure operations and synchronize it with the city multimodal mobility systems. I'm Frederic Chambour, founder of Avium. Next slide. The forecast that more than 70% of the large urban air mobility infrastructure will be built by those who today build airports. Those infrastructure companies have already understood that their current digital providers do not support the integrated approach required for air mobility with their aging technology. In fact, we speak with most of them, and for more than a year now, and it is clear that they would like to move away from a multi-provider system that work in silos, input-output system, and welcome an integrated systems measuring the variance between those data points that MIT research has estimated to be about 9,000 at the beginning of the industry, to continuously optimizes the operation and user services with goal to unlock the full economic potential of the urban air mobility ecosystem. Next slide. So we grabbed the opportunity to develop a SaaS application that will deliver a reliable and safe operation at vertiport with the objective to make the greatest measurable monetary impact for vertiport owners. The SaaS becomes an integral part of the mobility system connected, for example, with the city public transportation, carriers at airport, buses, or ride-hailing. Next slide. Our value proposition is to offer an unparalleled value to both vertiport owners and vertiport users, the customers of our customer. Our adaptive technology anticipates user needs, preventing queues and delays using AI modules. This personalized approach ensures a smooth and efficient journey, setting a standard for urban air mobility. Next slide. The vertiport operation SaaS operates remotely. We use command center offices led by domain experts, physical person. Each geopolitical region in the world will have its own command center, one in the US, one in the European Union, and one in some countries in Asia. Cluster of vertiports and single vertiports will be remotely controlled from their respective command center. Using two types of connections or two technology, we use the 2G to 6G network and satellites. We connect to all sensors, visual, atmospheric, scanners, and IoTs that allow Avium to run a fully automated real-time operations. And these are the first steps towards full autonomy. Next slide. VTOL aircraft operators pay their assets and their infrastructure usage at vertiports. The vertiport owner pays a license fee to us for the use of our services. The license has a cap on the total annual number of flights so that we can benefit from growth, and the overage is paid on a pay-per-flight model. Avium services are value-based pricing. We aim at shifting the customer seeing software as it is today for airport as a cost burden to seeing our technology as an investment that contributes to their success. Next slide. So we have analyzed the market beyond social media noise and marketing activities, and we anticipate that in Q4 2024, the Middle East region, mainly Dubai and Riyadh, will have the first vertiport operation, followed immediately by the United States in Q1 2025. This will be followed as well very closely by your major European cities, just a couple. We also believe that the adoption rate will be significantly faster in the North American continent than it will be in Europe, the expansion across smaller cities. Since over a year, we're exchanging with our future customers. Our current software version reflects those discussions and those regular iteration with them and team of experts and our advisors. Avium will reach a beta version by Q3 2024. This timetable coincides nicely with the anticipated certification of VTOL aircraft by the aviation authorities and some vertiport projects that we are in connection with. As a risk mitigation, our go-to-market includes the retrofitting of existing heliports to offer mixed operation of helicopter and eVTOLs. This measure strengthens our market penetration forecast. Next slide. Only few companies are today claiming the development of a similar software to operate vertiports. For those who are service provider today, you can find them below the arrow line. They have built their technology in the 80s, in the 90s. They're very expensive and risk averse. Hence, what they did so far, they tweaked their existing product lines to fit the narrative of the advanced air mobility. But this is not a proper viable solution for vertiports owners. Above the vector line, you can find a couple of startups. However, currently we can see that one offers small modules that will work on very small vertiports, and the other one is a vertiport developer with the aim of developing their own technology. So we, at this stage of our development, we don't see really a serious contender. Next slide. So our team, as you can most probably hear by my accent, our team speaks English, French, and German, and we have international experience in air transportation, operations, management, CEO, COO levels. Matt has an extensive experience in sustainable finance, and through our universities, we obviously have access to great connections and as well great research. Next slide. Our financial projection. So KPMG says 2030, the industry will be valued at 30 billion. And they're not the highest, they're not the smallest, about the five big one that's made those projections. Early stage revenue for us will come from a conservative 10% out of those 30 billion. And the early stage revenue will be integrating by third parties, aircraft, infrastructures, and slowly when we start in 2025, we will see the first license revenue kicking in. The growing ratio that you can observe on the table between the number of vertiports and the annual revenue is from Avium growing product value. As we are a value-praised product, the growing of features and value for the vertiports will increase the fee and as a result vary the ratio as well. So our technology is set up to allow for smooth and inexpensive scalability. Next slide. Today, we ask for 5 million for our seed round with a runway of about 8 to 10 months. The fund utilization will be up to 80% for the developers, and the rest will be split between marketing events and administration. Next slide. On the traction side, all our partners are expert in their respective fields. Some of them are just very unique in what they can do and serve the advanced air mobility. Together, they represent the primary stakeholders to develop and run a vertiport. On the middle line to the left, you can see the Presence Care. Presence has a product that are our mobile lab. And what we are attempting to do here is to work on a dual use application of our software with the NATO forces to operate upstream and downstream drones in contaminated theaters. Next slide. So thank you very much for your time and attention. We're thrilled to extend our invitation to those investors to join us on this transformative journey towards revolutionizing city mobility, one of the most significant advancements of the last decade. As we embark on this journey, we would like to insist that we recognize the critical importance of sustainability in shaping the future of urban air mobility. Thank you.
Thank you, Frederic. And last up, we have our fifth startup, AeroFuse. AeroFuse builds fusion-powered aviation. Led by Ryan Weed and Rama Myers, AeroFuse is developing an air-breathing fusion engine dual-use technology to replace the chemical energy in jet fuel, enabling true zero-emissions long-haul aviation. The stage.
All right, thanks, Nate. I'm Ryan Weed, CEO and co-founder of AeroFuse, where, as Nate said, we're building fusion-powered propulsion systems to decarbonize aviation.
And hi, I'm Rama Myers, co-founder and COO. Next slide, please. So today, aviation represents about 2 to 3% of global carbon emissions. However, as other industries begin to bend their emissions curve and decarbonize, aviation is way off track. The industry will double over the coming decades and is at risk of becoming a quarter of global emissions. Next slide. A number of solutions are being developed. We've all heard of battery electric aircraft and hybrid aircraft like Ampaire. A number of folks are focusing on hydrogen propulsion via fuel cell or combustion. But if we look at where emissions are coming from, it's medium haul and long haul aviation, which combined represent almost 75% of emissions. What's alarming is that if we look at the solutions available to us in that space through to 2050, we don't really have any other option other than SAF, or sustainable aviation fuels. Next slide. SAF and all these solutions are going to be critical to the decarbonization effort, but the major issue with SAF is costs. Today, it's 2 to 8 times the price of jet fuel, and even out to 2050, it's forecasted to remain at 2 to 4 times the price of jet fuel. If we consider that airlines operate on very thin margins and that fuel represents up to 1/3 of their operating costs, it's inevitable that increasing SAF adoption will lead to significant price increases for tickets. Next slide. In aggregate, this is a $4 to $5 trillion problem. This green premium will cost the industry about a decade of revenues, or put another way, it's $175 billion spent each and every year through to 2050 to absorb that green premium. Next slide. This is why AeroFuse is focusing on fusion. What is fusion? Fusion is nature's power plant. It powers each and every star, including our sun. Fusion happens when you take 2 atoms and merge them together under high speeds, temperatures, and pressures. This creates energy, a lot of energy. Fusion fuels are millions of times more energy dense than fossil fuels, and we think we've got a way to unlock that for aviation. Next slide.
So traditionally, people think about fusion in 2 ways. One is magnetic confinement systems, where you use large magnets to confine fusion plasmas. And the other is inertial confinement, where you use pulsed lasers to compress hydrogen isotopes to fuse together. Next slide. These approaches are very large. They're not going to fit into an airplane. And you can see pictures of two of the most famous plasma confinement devices on this page. On the right, you see ITER. You can see a human for scale. These are very large approaches. On the left, you see the National Ignition Facility, it's size of 3 football fields. The problem here is that not only the size is large, but the cost for developing these systems is large, which extends the timelines. Next slide. Over the last few decades, we've seen an explosion in alternative approaches to fusion. And these are typically hybrid approaches where you have a combination of magnetic and inertial confinement or electrostatic, Z-pinch, or other approaches to plasma confinement that can lead to much smaller system size and faster design iterations. And you can see a picture there of one of these systems with the human for scale. Next slide. So the opportunity here is that not only have we achieved break-even or more energy out than in a fusion system at the National Ignition Facility last year, but we are taking advantage of more than 100 years of development and efficiency in jet turbines. So we think that propulsion will be the first application of fusion energy long before fusion is powering the grid. Next slide. The key challenge that we're addressing is bridging the gap between the temperature and pressure regimes of a fusion plasma, which operates at hundreds of millions of degrees in an ultra-high vacuum, with turbines which operate at a few thousand degrees, but at much higher pressure. There's really no solution that can bridge that gap now. We've patented a way to do this. Next slide, please. So the key technology here is extracting high energy charged particles from a fusion plasma across the membrane into and injecting their energy into a working fluid, in this case, air. So we've come up with an approach that we can efficiently do this heat exchange process and can be scaled to meters in size, which means it can be scaled to megawatts in power, which is relevant to aviation. Next slide. So simply, our heat exchanger will be applied to third-party fusion core providers to come up with a complete solution that can integrate into the Brayton cycle, which is what the jet turbines in your 737, for example, operate on. Next slide. Here's a diagram of how the system works. Essentially, we take a jet turbine, which is on the bottom. We take bypass air from the compressor stage. We route it towards our heat exchanger. It then is redirected. The hot air is redirected back into the combustion chamber or the turbine section, and that augments the fuel burn, and the heat, the enthalpy from the fusion plasma can be introduced into this Brayton cycle, reducing the amount of jet fuel burn. Next slide.
For our Generation 1 solutions, we think we can reduce jet fuel burn by between 30 and 50% during cruise, which is a significant number given this will lead to the reduction of CO2 per aircraft over a life of hundreds of thousands of tons. We also have a retrofit first strategy, which means that our technology will be compatible with aircraft rolling off the production line today that will be flying for the next 20, 30 years. This also increases our TAM. As a fortunate byproduct of fusion's energy density will also extend aircraft range and also lower operating costs, or the cost per available seat mile. Next slide. Our target markets are commercial and military aviation, and we're going to start with military, given we can leverage Air Force's certification pathway there. Fusion-powered unmanned aircrafts, such as collaborative combat drones or intelligence aircraft, will have the ability to stay airborne for weeks. We're also targeting fusion-powered tanker aircraft, such as KC-46, that will have extended endurance and deployment offload capability. Transport aircraft, such as C-17, will have the ability to deploy troops and cargo to austere airfields without the need to refuel in between mission legs. On the commercial side, 40,000 narrow-body and wide-body aircraft will be delivered over the coming decades. And we want to eat away at jet fuel revenues, which today are 250 billion and are doubling to 500 billion over the next decade. Next slide. Importantly, unlike electric aircraft and hydrogen-powered aircraft, fusion propulsion allows airlines to decarbonize and adopt this zero emissions fuel without compromising on their passenger capacity. This is just an example of a 777X. Importantly, airlines will also have that extended range, which allows them to serve more point-to-point destinations. That's more direct flights and fewer connections, fewer emissions. Our go-to-market strategy is to partner with airframe OEMs, engine OEMs to integrate, design, certify, and introduce this solution into airline customers. Next slide.
So far, we've filed 4 provisional patents that cover the heat exchanger as well as the integration into a jet turbine system. We have partnerships with the leading compact fusion teams in the US, as well as a Phase 1 SBIR contract from the Air Force to look at integrating a fusion-powered propulsion system onto future tankers. We've simulated the heat exchanger as well as the engine cycle and stood up a lab at UC Berkeley Department of Nuclear Engineering. Next slide. The plan over the next decade or so is to first raise $1 million pre-seed to de-risk the underlying heat exchanger material solution. That'll happen at UC Berkeley, where we have a helium ion beam to simulate a fusion reactor, and we'll test the material in the relevant environment, followed by integrating it into a real commercial off-the-shelf microturbine to de-risk the fuel cycle. We'll then leverage military programs, as Rama said, unmanned drone systems, going forward into larger scale demonstrations on sustainable aviation demonstrators like X-66, followed by commercial pilot programs. Next slide. This is the team. Myself and Rama are full-time, and Thomas McGuire is our plasma physicist, is part-time. And next slide. We have a group of advisors that fill in the gaps between regulatory and defense and nuclear advanced materials, as well as the commercial side. Next slide. Thanks, everyone.
Thank you.
Thank you, Ryan and Rama. And thanks to everyone. This has been a great demo day. I'm so excited for these founders to have the opportunity to present what they've been building over the past several months to you all. Thanks again to Kevin from Ampaire for joining our event today to present the keynote speech on what they're building at Ampaire. And I want to thank the audience for joining today. If you have any questions, which I saw some come through today, I will be sure to pass those along to all of the founders. And if you would like additional information or follow-ups, I can be a contact for you. You can reach out to me. At the end of this, I believe tomorrow, our marketing team is also going to send out materials for all of the founders, all of the startups you saw today. You'll see we'll have the pitch decks uploaded. I believe they're already on the website now. There's a video that you can rewatch. And yeah, we're just really excited for these founders. If you're interested in connecting with them, again, please reach out to me directly. All of you will receive a follow-up email with more information on how to connect with the founders directly or with me. And I couldn't end this without saying thank you to Alana Evans, our marketing manager. She put all of this together. Really appreciate all the hard work you put into this. And thanks. That's all, everyone. Have a great day.